Hey folks, welcome back. On the Z1-R Phase 5, I know I said I wasn't going to film any of it, but I want to show you some stuff regarding the swing arm. This is a DME widened but standard length swing arm that's supposed to be a standard or direct bolt-in on the Z1-R, but of course it's not. None of these are. And whoever says they are, in my opinion, they're lying. So here's the deal. We're going to have to do some modifications to it, and I'm going to show you that here in a bit. And it's going to be kind of tricky, but I need to show you the stock setup and how this thing mounts and where it mounts for you to understand the whole thing. And I think you'll find this interesting. All right, so the first thing I'll show you is where the stock swing arm goes inside between the frame, two sides of the frame, and there are two bosses. Essentially they are like tubular pipe pieces that they welded in between those gussets. You can see that one on the right side. That's above that brake spring that wraps around. You see that hole? Okay, that's the right side one. And then the left side one's a little easier to see. It's right there. Okay, so that's above those two bolts, nuts rather. So again, this is a pretty typical setup where you have these bosses, and again they're welded into these gussets on the frame, and they are perfectly concentric. And then you have a pivot bolt that comes through the nuts on this side. And then between or I should say what the swing arm actually rides on is a pivot spacer. And there's a specific dimension that has to be met between these two bosses that I just showed you. Okay? And that pivot spacer, and also essentially they're seals on the stock swing arm, but they're really thrust spacers on the end. Because this is all an engineered system as far as the width goes. So I'm going to try to explain this to you, what we need to do, and I'm going to try not to screw it up. But to do so, I'm going to have to show you the stock one first. All right, so I need to get two hands for that. Let me get you set up, and that way I can do it properly. Okay, so again, here's the stock swing arm. Now what I'm going to do here is I'm going to take off these caps, and these again are like sealing caps, but the thickness of the steel part is critical to the spacing. So you don't have side-to-side movement of the swing arm when everything's tightened up, and also so you don't crush the frame in. All right, so the pivot spacer in between is essentially taking that axial load when that pivot bolt is tightened. So let's take this off. We're going to slide out the pivot spacer here a little bit. So here's your pivot spacer, and the pivot spacer rides on those needle dick bearings that are in there, and it's a certain width that when you take that in consideration in the measurement side, you're going to have the pivot spacer sticking out from each side of the body, or the top head. I'll call it the head of the swing arm. So when this is on here, it's hitting only the spacer, but just slightly, because it also has to be able to contact the head here, because otherwise if it was just on the spacer, it would have some sideways thrust. It would move. We don't want that to happen. So when both of these are on here like this, what you have is that spacer is just a little bit proud, maybe only by a few thousandths of the head of this thing. And when everything's tightened up, you have allowable space in here as far as for it to move a little bit, because we don't want it to pinch. So this really has to be socked in with the bolt when this axial load is put on this thing. So when it turns, it's actually rotating on these guys. Whoops, like this. So this and this, as far as the side caps, is stationary because they're essentially bottoming on the spacer pivot, the pivot spacer rather, not on the sides here. Otherwise, it would bind the thing up. So the dimensions are pretty critical. You can kind of imagine that if this was a little cut back in relationship to this, it would hit the spacer, and this would fit fine on here, but you'd have some side-to-side movement of the entire swing arm. So that is how the stock one works. So we have to kind of do some finagling on this DME one to get it to work right. So we'll go over that right now, and I'll show you the dilemma we have, and tell you what we're going to do about it. All right, on this swing arm, if I might take a seat, You have a pivot pacer, yeah, a pivot spacer, just like on the stock swing arm. That spacer is right here, and you also have the head of it, and it's a set distance. And instead of the rubber pieces on the ends, this particular swing arm comes with these. They're very interesting. Let me show them to you. What you have here is a thrust washer. Okay, you can kind of see the bearings in there if I can get it back over to the side a little bit. And it's kind of like, I don't know what these are called or not. Well, it's little needle bearings, I guess, but it's like a flat needle bearing. They're quite interesting. They're quite nice. They're very smooth, and they certainly would work pretty well. They wouldn't seal anything worth a damn, but I think in these applications, it's not like these things are going to be run on a motocross track. So these go on in the ends just like they would on a stock swing arm with the rubber ones. But in this case, unlike the rubber ones, the hole in the end is slightly larger than the pivot spacer. On the stock swing arm, those rubber ones are the same size as the pivot bolt. So they shoulder up to the spacer and, of course, to the head of the swing arm. These guys do not do that. These guys essentially are thrusting the swing arm, or controlling the swing arm side-to-side thrust by the fact that they are a certain distance away from the end of the swing arm pivot when it's in position, and that generally would be with the swing arm pivot maybe a few thousandths proud of these things, or basically at the same point, because both this and this are going to shoulder up against those bosses I showed you in the frame. So here's the problem we have. The first problem I had was I tried inserting this and it doesn't fit. It's too big. It's too wide. All right. So then I took the pivot spacer out, and the pivot spacer itself, which I'll show you here, was too wide to fit between those parts that I showed you. So it wouldn't fit between there. So I took this and put it in the lathe, and it's a little too big to go down the throat of the spindle. So I set it up in the steady, and I took 10 thou off of each end, and that worked perfect. So now it fits up in there, and there might be 4 or 5 thousandths of play, if that. I mean, it's very close. It's not dragging, because I can't get it quite that tight. I don't have any way to measure that, so I kind of guessed at 10 thou a side, and it worked out. I think that's going to work out fine. All right, so inside here, of course, the head of it, you have these needle bearings, which are not pressed in on these. The instructions are you're supposed to Loctite them in place when you get to that point, and that works for me because the operations we're going to have to do, I need to have them out anyway. That saves me some hassle of having to drive them out. So let me show you what the problem is. So with these end thrust bearings in place, and if we put both of them in place, and we kind of split the distance on the clearance here to make sure that we're not skewing one way or the other, the pivot bushing, the pivot spacer rather, is just inside of these things. So it's about like that. You can kind of see that if I can zoom up on that. You can see that the thrust spacer, the thrust bearing here, whatever you want to call it, is actually proud of this pivot spacer. Now we know the pivot spacer is exactly the right length. It can't be any longer than that. So if these guys are not at that surface or slightly below it, then there's no way this is going to fit in because this is too wide. So the two of these spacers, one on each end, would be too wide for this thing to fit in. And that's the case that we have here, because again, this pivot spacer is exactly the right length after I cut it down a total of 20 thou. All right, 10 thou a side. So this leads us to a dilemma. Now I tried thinking about how I could use the rubber ones on here because they do fit. That doesn't help us at all though, because remember, those holes are the size of the bolt, not the size of these pivots. Like these are the size of the pivot, so they slip over the pivot spacer that is. And even if we did some modifications to the rubber ones, they're not going to thrust properly because they're on the end here. They're on the end and not set in where they contact the inside face here, this machined face of the head of the swing arm here. So you follow me so far? So if we had done that and I essentially cut, let's say I cut this back a little bit more to accommodate the thickness of those rubber ones, and then what would happen was this thing would slide back and forth. The pivot would move back and forth like this, and thus the swing arm, I should say this pivot would stay still, but the swing arm would move back and forth on the pivot side to side. It would thrust back and forth, and that would be a no-joy. So what we're going to have to do is we're going to have to use these, and I like them anyway. I like to use these things. These are nice. But we're going to have to modify the head of the swing arm here, so when these are in place and they're correct in their locations, okay, both of them are flush or slightly below, maybe a couple of thou, of the swing arm pivot spacer, yeah. Number one, we know it'll fit in that scenario because this pivot spacer fits. Okay, and number two, if we have it about the same level on the outside here, or maybe just a couple of thou proud, we know that it's going to thrust properly and also not pinch, because if it was hitting these first and then the pivot spacer, it would bind these up, and then the thing wouldn't go up and down. It wouldn't articulate properly. So this is kind of threading the needle here a little bit. We have to modify the head of the swing arm again, so when these things are in place, they're at the right offset from those thrust bearings here, and not too loose and not too tight. So how we're going to do that is we're going to make some measurements, and then I'm going to fixture this up in the mill, and we're going to side mill both sides with like a 3/4 inch end mill. We're going to side mill it, and we're going to tram tram it in based on this machine surface. We got a nice machine surface. We can run an indicator back and forth to get this thing running right, and both axes, left and right and up and down. And then, if we're up and down, we may have to shim it a little bit, and then we'll cut the appropriate amount off. The problem is I don't know what the appropriate amount is, because it's very difficult to measure. I'm trying to come up with a way to do that. So I'm going to take you over to the mill to an idea that I have as far as temporarily fixturing this thing up on its side. So we have this. So we have one of these guys flat and pushed down to the mill table. So this plane will be exactly the same. In other words, in line, flush. And then we'll measure the other side and then just divide it in half, because I think that's the only accurate way to do this, because this is a critical measurement. So let's go over there and I'll show you what I got in mind. Okay, so I got a 1, 2, 3 block and my Starrett square that I got at the flywheelers, and I'm getting this as ident as possible, but this is not the critical thing. I need this as flat as possible down here, so I can't really rely on this 100%. It's just a reference. What I did to make sure that it's flat is I got a 1.5 thou feeler gauge. I'm working my way around, and it's got to be even. There's a little bit of a radius on the outside of this, so it's going to go in a slight bit. But as long as it goes in and stops about the same all around it, then I know this thing is almost perfectly flat or in line with the table. Okay? Now, the next thing I do is I take and make sure, and I think I can have you hear this, when this thing sits down, it's got to sit on the table flat. So I make sure that it does by kind of hitting it like that. It's not banging against the thrust bearing on the other side. It's definitely through the hole. So right now, this pivot, the pivot spacer, and the outside of this bearing, or this thrust bearing down here, are in perfect alignment, because they're sitting on, very flat and in line with the mill table. So now all we have to do is put this guy on top, all right, and hold it. And the reason why I'm fixturing it is because it's kind of hard to do this without it moving around unless you got it fixtured. Plus I can test it, with the feeler gauge, feel them up gauge. So the first thing I'm going to do is test the depth mic. Go on the flat of the table. It's reading about a 1/2 thou high. This needs to be adjusted, but I'm not going to do it right now. It's close enough. How you adjust these is you spin this nut on the rod itself, and that changes the reference between where this connects to the, or this bottoms out in the on the the thimble part of this, and how much it'll protrude out. But that's close enough. Within a 1/2 thou, I'm good. So I know I'm a 1/2 thou out, but that's okay. Now I'm going to go ahead and measure the depth mic from the outside surface of this thrust bearing to the inside of that that surface of the pivot spacer. Okay, and I'm going to check in a couple of spots. This is a little fiddly because there's that center one is in there, and it wants to hang this thing up. We're going to make a couple of measurements, see what it is, and we're measuring just under 50 thou, so 25, about 46 thou. That kind of jives with what I got just holding it and checking both sides, kind of splitting the difference before with a depth mic. I got about 25 a side, so that is jiving with a different way to measure it. So let me check it again here. 45. And the important thing is you got to make sure that you're not hung up on that. This thrust bearing has that center piece, which is the bearing itself. So yeah, we're getting pretty consistent at 45 thou. So 50 would be right there. So you see, 45 thou is at the 20 because it's before the half mark or the 50 mark, hash mark on the micrometer. Yeah, so that's whoops. I told you this thing's fiddly. Yeah, so that's just under 45. 43 to be exact. And we're going to, like I said, we're going to check it a couple times here and make sure we got a repeatable number. It's got to be repeatable. Yeah, we're getting 44. So I'd say 43 to 45, depending on the feel and the movement of the mic, because this isn't exactly the most stable thing to be resting the main body of the micrometer on to get a good feel. But that's why I got a fixture so I can press down on it. So that's 45. So we're going to go with 45 thou, which again jives what I thought I was getting by just holding these things on the table and then measuring from one side to the other and kind of splitting the distance, you know, feel them, the distance in, and then measuring it. I thought I got 25 a side, which is 50. So if I'm getting 45 here, then I'd consider that number validated. So that's what we're going to do. So we'll make a note of that number, write it down, and then I have to set this completely up now in a different fixturing so we can side mill essentially half of that, but we're going to leave about 5 thou, so it's half less 5 thou. So let's say we're going to do 45, okay? We would do normally 22.5 for 45, so we're going to go at about 18 thou or so. And at, you know, 17, 18 thou, leave about 4 or 5 thou, 6 thou, because I want to make sure I don't take too much off. I can file that. I can file 4 or 5 thou in pretty evenly with a hand file, but taking off 20 or 30, you know, 25 thou or so with a file is going to be, or a grinder is not going to be accurate enough. In other words, I want to leave a few thou. All right. So again, 25 and 25 would be 50. So if we're going to do 45, then 22.5. But we're going to back that off to about 18, I'd say. And that's how much we'll take off each side. And that would be this tube here, this head. On each side, we're going to make it even, the same amount on each side. And that way, when we put this back on, we should have it very close to having this line up with this surface on both sides. And we may need to take a little bit more so it's a little bit more proud. We're going to sneak up on this is what I'm trying to say. Okay, here's the fixturing. 3 straps. The adjustable blocks in the back are supporting the rear of this strap, not the front tube. It's not spanning the two, in other words, down to a T-slot. And then these 2 guys on the side. I just have them snugged right now. I got my stair at 196 ready to go. And what I'm going to do is I'm going to tram in both sides. I did check to make sure my X was good enough. This is a fairly small mill to be able to do both sides in the same setup. If they both tram in the same right now, that's why I want to look at it. If they're really close, then we're going to do them in the same setup. That's why I got all these straps on here. Plus, you know, we're doing a tube, an open tube with a 3/4 inch end mill with a 1/2 inch shank. And what I don't want, I'm not going to run it too terribly fast because I'm going to take really light cuts and we'll sneak up on that total amount, which I wrote down over here, which is covered up by one of the blocks. Yeah, nice, but I remember what it was, 45 thou, and we're going to back it off to about, instead of 22.5, we're going to back it off to about 18. and then we'll take the rest by hand if necessary. So what we're going to do at this point is put you in the stand here. We'll get her trammed in and see what happens. I kind of eyed it in, you know, eyeing in the header tube there with one of the T-slots. So just going to get a little bit of preload on. I don't want much. I don't have a flat button head for this indicator. I wish I did, but this is a round head, so it should be okay. So we're 0 there, of course, where we zeroed out. Take a look over here. Damn close, but not close enough. All right, so we are a little high. So we want to move that technically away from the indicator a little bit. So what I need to do is do a little tap, if it'll move that way. Sometimes they don't move that way depending on how it's fixtured. Oh, dead nuts, look at that. Okay, so 0. And almost 0, half a thou rather. Now we'll go in the middle of it this way. We're going to go on the Z-axis. We're going to run the coil up and down, see how it looks that way. I had to change my indicator fixturing. That was a dumb idea. Whose idea was that? So I rechecked side to side and I made one adjustment, but I didn't have to do anything up and down. See, we got 0 there, which is pretty neat. That's neat. So we're at the top, then we go down, boom. That's a thou. If not right on. Maybe it's half a thou or so rather. So that's pretty good. I'm really kind of surprised at that, because this thing did, you know, give me a little bit of a rock on the 1, 2, 3 blocks, but I tried to minimize it when I set it up. Yeah, so I take that all day long and twice on Tuesday. Of course, today's Friday. We'll double check this side to side. Along the Y, should be the same, 0 or a thou maybe. That's close enough, definitely. So I'm happy with that. I mean, I'm happy with the fact that we're good enough on this side. Now we're going to do off camera is flip it around and check the other side. And if that jives where we have like a thou or so, you know, off on any particular, you know, Z axis up and down, or you know, the Y axis in and out, then we're just going to leave it and finish tightening these guys down. All right, and then we'll make the cut. And like I said, I think we're going to do about 18, 19. I'm rethinking that. I might do 20. I hate doing too much though. Probably 18, 19. I don't know. We'll figure it out as we go, because I'm going to have to use my other indicator. I have a DRO. I'll have to use an indicator on the table. Anyway, we're going to have to dial that in with an indicator, because I don't have a DRO yet on this machine. All right. Okay folks, so I got that milled. I took exactly 20 off each side. and then I just went slowly back over climb milling it just to take like a spring cut. And I think the surface finish is excellent on both sides. I know that mill not running at the right RPM. It's a little on the slow side, but it did the job. I didn't really feel like changing the belts around. And I think I've figured out a way we can test it in situ, you know, in this setup. That way, in case I really screwed up, which of course I probably did anyway, we can make necessary adjustments if we need the mill to do that. So I'm going to put these, just slide these bearings in. Yeah, so as I suspected, I can feel it as it is right now. The outside is still a little proud. So what I'm going to do is I'm going to, I don't know what I'm going to do. I got to measure this somehow. Both of them are, yeah, I don't think it's close enough. Yeah, we may need to take off a little bit more. But I need to calculate that and figure out what. So since that pivot shaft is a little bit hard to move in there, I think I can just depth mic it into that without it moving. 14 thou right there. So we're about even just by feel. 15, yeah. So it's 15 thou on each side. Still with these proud of that. They really need to be about the same, which is kind of weird because the way we calculated it should be closer, a lot closer than that. But doesn't mean the mill cut it exactly right. Well, we may not be able to do this. Didn't anticipate it. We cut off that amount, and guess what? The counter bore is not deep enough to seat both of these bearings. This one is about flush, maybe a little proud, so we can't cut it anymore. It should be reading properly, but it can't because bearings are in the way. Let's take one out, and I bet you it will. But we're not going to be able to do that. We're going to have both in, so I'm not exactly sure what we're going to do with this, but it won't fit, so crap. So here's what we're going to have to do. This is going to be a very extensive operation, and I'm not going to film any of it. On this mill at least. If I had a horizontal mill, it'd be no problem, but we're going to have to set these up on end. I'm pretty sure I can get the head up high enough with my boring head in. That's going to consume a lot of Z-axis there, so I'm not really sure if it's going to work. But if I can make it fit, I'll have to test it first by putting this thing up all the way and then putting my boring head in, turning this thing just by hand and seeing if it'll clear. Then we're going to have to figure out a fixturing for this thing so it's standing up on end, and then not only get this thing dialed in as far as the center, but we have to run an indicator down it on 2 axes to make sure it's not off this way or that way. And then I can stick my boring head down and just clear that shoulder in there, you know, by, I don't know, we'll figure it out. I'll have to measure this and see how much it is, and we'll go a little bit more to make sure we got clearance in case we got to take a little bit more off. So, you know, let's say 20 thou, 30 thou, we'll have to move this shoulder in. You can see it. I don't know if you can see it in this picture. That's what I'm talking about, that shoulder that's in there. So, yeah, that's what we're going to have to do. It's not going to happen today. But, yeah, so this is all mock-up. I don't know if I mentioned that at first. This is really all mock-up right now. We're doing mock-up only. But I can't do anything until I can get this thing set in place so it doesn't thrust back and forth. It's where it is left and right, and it actually fits, which it just won't do. You know, it won't do on the current configuration until we modify it. So next time we pick up, hopefully I'll have it completed and we'll put it back in the bike and see if it fits. I mean, it'll fit at that point. And then, you know, the math says it'll fit. So at that point we'll get it back in and we can finish this video, which is just a little bit of the mock-up of the swing arm. And we'll get that rear wheel, which is right here, this Morris mag. We'll put it in there and see kind of how it looks. That'll finish this video up. But like I said, I'm not going to video any of the other stuff I need to do to try to bore that out a little bit more, that shoulder, because this is going to be a very extensive setup on a mill like this.
There must be another way.
So after taking off 20 thou off of each side in a side mill operation, as you can see from the clips, I ended up with dimension that I was unsure of at that point as far as whether I needed to take more off or not. So I stuck the bearings in because I wanted to remeasure. And unfortunately, when I saw this, this is a problem with this being proud of this surface. These need to be at or below this surface. These are the stock bearings that come with it. They're a certain width. These are 16 millimeter wide bearings, and the ones that and I don't know the diameter or whatever it is, but you know, stacked side to side, that's what you got. These things are like this when you take them out, and so if you held them up here, you'd have one here and one there, and there's a shoulder in here that these two bearings register up against. This is pretty much standard, like all the KZ1000s. There's a shoulder in there, and then two bearings on each side, two needle dick bearings, okay? So again, when you put this in like this, we got a problem with the fact that we can't size this anymore, because remember, this guy is sized for that. I took 10 thou off each side because this pivot spacer was too wide to go between the frame, and this fits really nice between the frames. So this is essentially a kind of like a go no go at this point. All right, so I'll show you what I ended up doing to fix this. All right, so let me just show you this side again with the pivot spacer in place. And again, you can see that you have a bearing that's a little proud of the outside surface, which is a no-go. We need to have this face that I just side milled register with the inside of this thrust washer, this thrust bearing washer, okay? But if you go over this side, you can see now that that bearing is actually down below it by about, I'd say about maybe 1.5 mils, 2 mils. And the reason why is because I got two shorter bearings. They came out of France. The original ones are 2216s rather, and I ordered two 2214s, which are the correct ID for the pivot, the correct OD for this bore, and just a little bit less long, or a little less long, a little narrower, I guess would be the word. And so these fit nice. So now I've got clearance to play because I ended up having to take 15 thou more off of each side. But I'll get to that here in a second. So when these are in, what you ultimately want is this pivot shaft to be exactly flush with the outside of this thrust washer, because both of these, remember, both of these, I showed you this before, both of these register with the inside of the frame, the bosses on the frame. So there's enough thickness to that it overlaps on both of these. So if one or the other is off, either you're going to pinch this or you're going to pinch that. And if you pinch the outside one, the swing arm's going to bind. If this is long, in other words, the pivot's long, then you're going to have side-to-side thrust issues. And you don't want either of those two things. And I friggin' nailed this dimension. I got it 15 thou more off each side, and after remeasuring it, because now I can remeasure. I can't remeasure it with it like this because I'm going to have an inaccurate measurement. And in fact, in an earlier clip, I'm kind of redoing that, going, you know, WTF, what's going on, you know? And then I realized that we had this proud, and that was throwing me off. All right, so the other problem I had was that I suspected that one or both of these bores were not square with the outside of this head. And I'll explain how I came to that conclusion and how I corrected that after measuring it here in the next clip. All right, so when I originally had this down on the mill, so this was down on a table and this side was sticking out. So this is the first side. The left side is the first side that I cut, and I indicated in the existing surface X and Y, and then I face milled that. I did not check for squareness to this bore at that point. I assumed that they were square. When I came over to this one though, which would be on the right side, okay, and I indicated this one in, remember the workpiece hasn't moved, these were off. So I actually tapped the workpiece around to indicate this bore in. Then I cut the initial 20 thou off. So that brings us to 20 and 20 off where we have this situation. All right, where we have that situation with it being proud. Then I had to stop, rethink, order some shorter bearings, and now I've got some wiggle room because now I can measure it. So when I put the two shorter bearings in and I put these these thrust washers on with the pivot, I can actually measure the distance again, just like I did earlier in the video, between the outside of this and the depth of the pivot. When I put one of them flush on a flat surface, and I measured the other side, divide that by 2, I came up with 30 thou, so 15 and 15 on the side is what I need to take off additionally. But I did not want to do that without making sure that it was square with the bore. So I had to make a tool for that because there's really not a whole lot I can do to indicate this. I mean, I could stick my tenths indicator in here and indicate this back and forth, but it isn't a very long, wide surface, and that's kind of hard to do. So what I did was I went over to the lathe. I found a piece of what is it, fork tubing left over, and this was cut this way. There was a larger and a smaller diameter, and this diameter here was just bigger than what this was nominally. So I took this one, I skimmed down the outer surface first to true it up, spun it around, indicated in on this larger surface I just cut to get it 0, 0 on the indicator. You know, bumped it around. Even in the 3-jaw you can do that. And then I cut this to fit this, and this thing fits perfect. So it's a nice solid fit. You know, it slips in and out, but there's virtually no play in it. Now I've got a true surface to indicate. So what I did first was I came back over here. Remember, this is the first one I did the 20 thou cut on. Of course, there's no bearings in it, you know, when I did that, when I did this 15 thou, right? First thing I did was indicate the face in. Then I shoved this tool in, and then I indicated across it. And luckily, it was within a couple thou. So this one was not out very far. So again, I'm comparing the face of this that I already cut off 20 thou off of, and I had indicated that in before, to what it is now, and as far as how square it is to the hole. Luckily, this one was good. So I had already bumped the workpiece around to square this previously cut piece side in rather. So I left it alone, and I came over here again, and I put it in here, and then indicated across this guy, and it was relatively close. All right, within a few, maybe 3 thou, close enough. Okay. So I said, well, the bores are fairly concentric or fairly in line with each other. I'm not too worried about them. But remember, I had cut this one as well, 20 thou, and I had bumped the workpiece around to match that existing or previous surface that I cut. And when I have this squared up to that, and the bores are basically concentric, this face was out, like 8 thou. And that was, again, because I bumped it around to accommodate, you know, to basically duplicate what was there before. So I said, I don't want that because I really need this square. It's really important that these two sides are square. All right, where these go in opposite each other, and that axial load is put in, because you don't want it doing this. You don't want it pulling it at an angle, you know, from the bosses there, okay? So I said, all right, since I had already checked it with this on both sides, and that side was square to this, I just cut this side as it is. I didn't move it around, in other words. But that left me with a challenge here because I'm about 8 thou off, so I have a high and a low, all right? And so when I know I need to take 15 thou off of it. So if you're going to do something like this, you have to think about it. You got to take 15 thou off the high, because when you're measuring it, and this thing is flat up against something, and you got that pivot sticking out, it's going to be always taking the high side. In other words, measuring off the high side, because that's the edge that's registering with whatever you're putting it against to measure. So I touched off the side mill, the end mill, the side of the end mill on the high side, and then I dialed in 5 thousandths 3 times and 15 thousandths cuts, and took 15 thou off this side. So now both of these are parallel to one another, and I know they're reasonably square to the bores. And that led me to the final disposition of when I put the two, and you can see the difference in the bearings here. When I put the two bearings in with the narrower bearings, that's tough to say, in there, and I put the pivot in, and I put these guys on, the pivot sticking out is exactly flush with the outside surface. So long explanation, but I wanted to show you what I did to accommodate for this. You know, this precision stuff takes time, you know, so all what I just described to you, I did over a period of probably about 2.5 hours. So, you know, it just takes time to do. Then I just deburred it. I got to do a little bit more deburring on the outside here. I'm not too worried about that, because this whole thing has got to get powder coated or painted or whatever anyway. There's a bunch of nicks in it. I wasn't too concerned about that, you know, banging it around on the mill table, because I knew this was going to have to get redone, and that's just what happens when you got to machine stuff, you know. I've got that machined. I mean, I nailed that dimension to bring the overall outer edge of the front of the swing arm, or the head of the swing arm, when those two thrust bearings are installed, to exactly the same size as the inner pivot tube, the tube that goes through, which is the axial load tube part of this thing. So when you tighten this pivot bolt, you're not pinching directly on the outside of the head of the swing arm, but you're actually transmitting that load through the pivot. But it has to contact the swing arm, those thrust bearings at the exact same time. Otherwise, one will be bound up or it'll be loose. So if the pivot was a little long, then this thing would move back and forth a little bit. It would thrust back and forth. And if it was a little short, then it would pinch on the head itself more than the pivot, and it would bind this thing. And I nailed that freaking dimension. This thing is pretty tight. I don't think I have that nut completely up torque yet, but I got it really tight just by using a 1/2-inch ratchet and a socket. And this thing is perfect. I got smooth motion. There's absolutely no thrust, no twisting, no nothing. So I'm real happy with that. The other parts of this, unfortunately, I'm not as happy with. Now, you can see the Hagen shock, the supposed upside down shocks, which aren't upside down. Remember, the valving is the reason why these are like that. And you can see the dampening adjustment is down there, which is where it should be, at the bottom of the shock. Anyway, if you hold this up here where it wants to go, it's off 3/8 of an inch or so, close to a half, maybe 3/8. So about 10 mil. Where these things really, these parts here, the mounts on the swing arm should be outboard about 10 mil more. You can get them in, but you got to fight this. And then what happens is, because they're angled in a little bit, it angles the nut, or the bolt rather, and it doesn't want to capture the thread properly. So that leads to it binding. I actually had to grind these a little bit to get it to fit at all. I didn't want to do that, but it's the way it is. And so we got it to fit and I got it to work, but that was just for that part of the mock-up. So let me hook one of them up here to get the swing arm level, or at least stick them into the slot so it'll hold it up, and I'll show you the rest of this. All right, so this is where we're at as far as the alignment of the wheel itself. Now, I like the way the swing arm came out. I don't know about the height yet, because if I'm going to cut these off and move them outboard a little bit, I may want to move them this way and this way. We'll do that last. And then actually second to the last, because the last thing is it'll come apart and you'll have to have it re-powder coated, or I'll paint it or something. Because it's pretty banged up from being on the mill and stuff, but I really didn't care about that because I knew it was going to get refinished. So anyway, where was I? The number one thing, the only thing that matters, is the alignment of the chain to the rear wheel, to make sure that they are dead straight. Otherwise we got big problems. All right, premature chain wear, the whole works. All right, now this is a 630 chain, which is the original chain, the OEM size for this. And according to the information we got from where my customer bought this, and I thought it was a company, but it was an individual. This individual rather has experience putting this swing arm with the fat wheels and the Morris mags and so forth on Z1s, the 900s. And that's probably why it wasn't a direct fit on this, because these Z1-R frames are slightly different. So what he said was, you got to do the 630 to 530 chain conversion, and Z1 Enterprises has that setup. It comes with the sprockets, the chain, and some spacers that you can put in or take out as you need. So I did talk to Sam at Z1 Enterprises yesterday, and he sent me a link for one. There's a couple of them on their site. One for the 900, and then one for the 77 to 80 KZ100, KZ100s, yeah, KZ1000s, which of course this would fall into that. So I haven't taken a look at it yet, but I'll probably end up ordering that one. The way you do that is you take your sprocket, count the number of teeth if you want to maintain the exact setup that you have at this, at that particular time. This I believe is stock, and that is stock. And the chain is stock, which is 92 links. You take that, that, and that, and you multiply the sprocket teeth and the links by 1.2, and you come up with a conversion from 630 to 530. So I still need to do that, as I said, and then we'll go ahead and get that ordered in, because again, the number one thing is, and the only thing, is the alignment of the chain to the sprocket. That is your, that is your sweet spot. You have to hit that. Now the other thing you gotta consider, of course, is when the chain is around the sprocket and the wheel is installed and you're setting up the spacers, not only does the chain have to be dead straight, so the rear sprocket is straight with the front, but hopefully that lands you with your wheel properly between between the frame here, okay? In other words, the wheel's not offset to the front wheel. Now, I'm pretty sure the way they engineer these things, even these aftermarkets like the Morris's, the offset on the hub itself, on the wheel, is engineered so when you are properly set up with a chain, sprocket, and everything's bolted up to the wheel, and then you do your proper spacing to get that straight, it should be in line with the frame. I'm hoping, at least. But unfortunately I can't go any further on it right now without that kit. I wanted to just at least put the the 630 sprocket. I took it off the hub there and wanted to slip it over. I don't have the wheel here right now, it's out in the shed, over the wheel, but the center of that where it registers won't fit over the register on the Morris mag, probably because of the freaking powder coating. And I'm certainly not going to modify or try to scrape any of that off on the wheel, because that's not the sprocket that's going to be on here. So I got to wait for that to come in and then try to fit it, and that's got to register with the hub on the wheel, and I can temporarily bolt it up with the supplied hardware, and then we can come back to this at a later time, put the swing arm back in, and because I'm going to be changing it back out to the old one so we can roll this around, and the old setup, and then we can check all those offsets, and we can see how this thing's going to actually line up. Then we got to play with the axles. I got a couple more out in the shed as well. I think we can come up with something for that. These are the adjusters that came with it, so we'll keep those with that as well. And then once we get it to that point, we can really get an idea, a firm idea of tire size. Now I don't think a customer is going to have any problem with any tire size. I forgot what he said he wanted to put on it, like I don't know, 150 or something like that. I don't know, but I don't think he's going to have any problem at all, because when I put the wheel in here, I did have the rim with a axle going through yesterday. I didn't shoot that, unfortunately, but when I put that in, I mean, there is a ton of room in here, both upwards, side to side, and the whole shebang. And we also don't have any clearance issues with the brake lever or the holder, the bolt for the muffler hold down, which is actually, I guess you want to call it the passenger foot peg mounts too. I don't really know what Kawasaki was thinking about that, because when this bike came, it had some clamp-on job on this side, and the proper one down in that part over there, it's sticking out just like this one is here. So I don't know. I don't think he's going to deal with that. I'm not going to mess with it either. I'm not going to be accommodating for anything like that. All I need to do is get this thing to fit. And again, I'm real happy with the way the machining came out on the head side, with the pivot up here rather, where this thing is just dead nuts. I mean, I nailed that dimension, so that worked out pretty well. So again, that's a wrap on this one. Hope you got something out of it. It's kind of more interesting than learning experience, just or learning, video. Just kind of interesting what I'm doing with it. But you keep tabs on this by subscribing, ringing the bell, liking the video, and sharing. And with that notification bell rung or clicked, whatever you want to call it, you can get notified when I put more crap up on this or other projects that I'm doing. So again, you know the drill. Speaking of drill, I need to go drill some holes. Got to do some work on the trailer. Thanks for watching. Catch you on next video.